Today we are going to be looking at section 5 of section 7 of chapter 5, inequalities in two triangles. Okay, so we've got some similarities to what we did yesterday when we looked at inequalities in one triangle, but there's also something that's going to be different. So as we go through these notes, on the front side in your interactive notebook, we have two theorems that we're going to be working with today that have some similarities to what we were doing in that first section that we talked about yesterday. This time though, we're looking at two separate triangles instead of the individual triangle. So this first theorem says that if two sides of one triangle are congruent to two sides of the other triangle. So we always have to make sure we have that first. Okay? So I have one pair of congruent sides. I have a second pair of congruent sides. Okay? So we have to have two sides that are congruent. And the included angles, so angles A and X, are not congruent. Okay? Here we are told that angle A is greater than angle X, so they're not congruent. Okay? So as long as we have that set up, which is how they come up with this angle side inequality theorem, then the longer third side is opposite the larger included angle. So again, we're kind of looking at that similar to what we talked about yesterday. Okay? So since angle A is the bigger angle, its opposite side, side BC, is going to be greater than the opposite side, YZ. So just like we talked about yesterday, if you're a visual person, these triangles are very helpful. Okay? If you don't really need the pictures, again, we're looking at those three letters of the triangle. Triangle ABC. We've got angle A, which means it's side BC, that's the opposite. If we're working with angle X, the other two letters make up the opposite side, side YZ, which is the exact same, they just wrote it down here. Okay. But again, key piece with this is that we have to have those two pairs of sides that are congruent. Yes, Simon?
So basically all this is saying is that this is basically just the thing we learned yesterday, where the larger the angle, the larger the side opposite is.
Right. Okay. But that only works when we have two separate triangles, only if the other two sides are equal.
All right.
Okay? If all of the sides were different, then it wouldn't work that way. Okay? So sometimes they call that the hinge theorem, okay? Because if you think of opening a door, okay, the further you open that up, the bigger that angle, that space is in the doorway. So that's why they sometimes refer to it as the hinge theorem. Just like what we worked with yesterday, if we knew angles, we could compare sides. And then if we knew sides, we could compare angles. Works both ways with this one too. So the converse, we still have to have two sides of a triangle that are congruent to the two sides of another. So we still have to see the congruency for two sides. Okay. Then this time we know the comparison of the third side. So this time the third sides are not congruent. So we know side BC is longer than side YZ. So then the larger included angle is opposite the longer third side. So if BC is the longest side, then angle A is the bigger angle. Thank you. So opposite of YZ is angle X. So yet again, you're very visual, look at those pictures. If not so much, just think about the three letters. If we've got side BC, we haven't used the letter A. So opposite is angle A. Opposite of YZ is angle X. Okay? Need to make sure if we're working with angles, we need to have that angle symbol. If you're naming sides, we need to have that segment bar. Yes, Sarah?
My question being, do we have to like circle those congruent sides and everything? Like,
You don't need to circle those congruent sides on your paper. You definitely, though, want to look and make sure you have two sides that are congruent. Because if you don't, then you can't use this. You just wouldn't have enough information to make that determination. Okay, good question. So, going to use those two theorems. Number one says we want to, or it says what inequality relates side LN and side OQ. Okay, so again, when I look, I see those two sides that are congruent. So that's important to look at. So now I'm going to look at the angles, 125 and 78. So the big angle is the 125. So that means the long side is LN. So LN is greater than OQ. Okay, so we're just going to be putting in an inequality symbol in between those two. Number two, okay, I see one pair of congruent sides. Do I have a second pair of congruent sides?
Yeah.
I do. Where?
the shared
Middle.
Okay. I have that shared side. So we need to make sure we look for that. Okay. Okay. So I do have two pairs of sides that are congruent. This time they didn't give me angles. They gave me the third side, 36 and 34. So 36 is the longest, which means angle 1 is the largest angle. So angle 1 is greater than angle 2. Okay. So in a lot of the lesson, we're just making those comparisons. Okay, very similar to what we did with just one triangle. With the next questions, they are asking us for a range of values. We did a range of values for the one triangle by subtracting the 2 and adding the 2 to get that range. This range is done completely different when we have two different triangles. Okay. So to start out, we're comparing these two triangles again. I see that I have two pairs of sides that are the same. I know the third side. Okay. So I need to solve for x. So I'm working with this angle down here, which is the 3x plus 18. I know this angle in the other triangle is how much? 90. Okay. So I'm going to compare these two angles. Okay. So my 3x plus 18, does that have to be less than 90 or greater than 90?
Less than.
It's going to be less than, because 7, when I look at the 7 and 9, okay, 7's smaller, so that means the 3x plus 18 is smaller. So 3x plus 18 is less than 90. I also will come back and solve it in a minute, But if we have a range, we also have to have a second number. So we're going to have a small number and a big number. Okay. So we also have to have another piece for that range. To find the second piece, I'm going to take this 3x plus 18. And because we're talking about an angle measure, okay, this 3x plus 18 has to be greater than 0. Okay, it can't be 0, it can't be a negative, because we're talking about an angle. So it's going to be 3x plus 18 is greater than 0.
And that's the answer.
No, now we're going to have to solve each of those. Okay? So let's come back to this first one. Do the algebra. So we're going to subtract 18. So 3x is less than 72. So I divide by 3. X is less than 24. When I come back to the second piece, I'm going to subtract 18. 3x is greater than negative 18. Then I'll divide by 3. X is greater than negative 6. Okay. So now I'm going to write that as a compound inequality, just like we did yesterday. Okay. So I start with my smaller number. So I'm going to start with the negative 6. I use that less than symbol. My variable x. Another less than symbol. And then the 24. So that is the way my range looks. Okay? So just like yesterday, the small one's always on the left, big one's on the right. We're always using those less than symbols. Number 4. Okay? Number 4 looks a little confusing just because we've got this great big triangle on the outside. We see 3 triangles on the inside. But again, if I focus in on those sides that are marked, okay, I have one pair of corresponding sides that are congruent. I have a second pair. So the 2 triangles I'm working with are triangle ABE and triangle EDC. I know the third sides. So my focus is on this 5x plus 7, because that's where my variable is. So 5x plus 7, this angle, needs to be compared with the 112. Is it going to be greater than 112 or less than? Okay. It's going to be less than, because 12 is smaller than 15. So the angle is smaller. So less than 112. For the other part, I take that 5x plus 7 again. Second part is always going to be greater than 0. So now I have to do the algebra. I'm going to subtract 7. 5x is less than 105. Divide by 5. X is less than 21. When I do the other part, subtract 7. 5x is greater than negative 7. Divide by 5. X is less than negative 7 over 5. And you can, greater than, and you can leave it as that improper fraction. Okay? You don't need to make it a mixed number. You don't need to make it a decimal. Okay?
I'm still confused on where you found the 0 and the second one.
This piece?
Yeah.
Okay. It's just always going to be this angle piece. Okay? and it's always greater than 0. Okay, because this is an angle measure. If we're measuring an angle, it has to be bigger than 0. Okay, it has to be a positive number. We can't have an angle size that's negative. Okay, so we just know it always has to be greater than 0. Okay. So then we want to write it as a compound inequality. So that negative 7/5 less than symbol variable x less than symbol big number 21. And that's what would be our range for x. One more problem. So first of all, do I have 2 pairs of sides that are congruent?
Yeah.
Yes, okay, because again, I've got that shared side, which is congruent to itself, and they've given me the third side. Okay. So, piece I need to work with has the variable, so it's that 5k minus 12. Okay. Is that going to be less than or greater than the 38? It is less than the 38 because 18 is less than 19. For the other part, we're taking again that 5k minus 12, and it has to be greater than 0. So then we're ready to do the algebra. So I'm going to add 12 to both sides. 5k is less than 50. So I divide by 5. K is less than 10. For the second part, I'm going to add 12. 5k is greater than 12. Divide by 5. K is greater than 12/5. And again, we can leave it as that improper fraction. So 12/5 less than K less than 10. And that is my answer.